Okay, so let's begin with the basic trigonometry, right? That's very basics. So what is an angle? We know it's the geometrical shape when two lines meet together, okay, at a point. So this shape is known as an angle. Okay, how do we measure an angle? So suppose we have this circle, okay, and this is suppose an arc of the circle. It makes some angle theta at the center of circle, okay, and this angle theta is measured as, it is length of the arc, that is length of this arc AB divided by the radius, okay. So when we measure angle this way, the unit of this measurement is radians, right? So theta is equal to what? S divided by R. This is how we measure the angle, okay. After that, there is another unit for the measurement of an angle. That another unit is called as degree, okay. So now what is the degree measurement? So the angle subtended by the circumference of the circle, it is equal to 360 degrees, right? Angle subtended by circumference of circle, it is equal to 360 in degrees. So now in radians, what will be that angle? So the maximum angle subtended by the circumference of circle at the center, it is maximum arc length, that will be equal to what? The circumference itself divided by the radius, okay. So that is 2 pi r divided by r, and therefore your angle is equal to what? 2 pi radians, right? After that, now so this 2 pi radians must be equal to what? 360 degrees, because angle subtended by circle in radians it is 2 pi, in degrees it is what? 360 degrees. So 2 pi radians is equal to 360 degrees. So therefore 1 radian would be equal to what? 360 divided by 2 pi, okay. 1 radian is equal to 360 divided by 2 pi. That is, if you divide by 2, it will come out to be equal to 180 by pi, okay. So this is radian to degree conversion. Now at any given time, suppose you are asked what's the conversion, okay, 1 radian, suppose angle is pi by 2 in radians, what will that be equal to in degrees? So you should apply this formula, okay. Then degree to radian, so now we'll use same equation, just take that 360 degrees on other side, so it will be 2 pi divided by 360 degrees, that means it will be pi by 180 in radians, okay. It's pi by 180, right? So these formulae you have to by heart, okay. So then there are another units, smaller units for an angle. So each degree is divided in 60 equal parts, and each of those parts is known as a minute, okay. So 1 degree is equal to 60 minutes, and that is 1 degree is equal to what? 60 minutes. It's represented like this. So it is 60 dash, you can say, okay. So 1 minute is and 1 minute is further divided into 60 equal parts. So 1 minute is equal to 60 seconds. That is 1 minute is equal to 60 this double dash, okay. So I guess till here nobody will have any problem, right? This is very basic thing. All right, very good. Yeah, tell me, Yamini. No problem. Okay, you can just speak up, right? All right. After that, next is the trigonometric ratios, and I'm sure you know this thing also. Yeah. I will share the notes after the class. Okay, no problem. All right. Then just uploading these videos will take some time, okay, because they have to be uploaded on YouTube or some other platform, and after that I can upload them on website, okay. Anyways, so okay, So let's talk about the trigonometric ratios. So what are trigonometric ratios? So now suppose we take this triangle. This is special kind of triangle, not any triangle. This is called as right angle triangle. What is a right angle triangle? It's and a triangle has three angles. Okay, so one of the angles is equal to 90 degrees, right? So this is called as 90 degree means a right angle. So one angle is 90 degrees and then the triangle would be called as a right angled triangle. So this is a right angled triangle. Okay, so this side, the longest side, is known as hypotenuse. Then suppose this triangle is resting on this side, so we can call it a base. Then this remaining side is known as height. Okay, so this is just nomenclature. So this is suppose the base, it's denoted by x, this is height denoted by y, and this is hypotenuse denoted by h, right? Very simple. Then we have the Pythagoras theorem. Okay, again I'm sure everybody knows this, but this is x square plus y square is equal to x square. Okay, so base is x, then height is y. If you take square of base plus square of height, then what do you get? Hypotenuse square. Okay, so this is the Pythagoras theorem. X square plus y square is equal to x square. Then we have standard trigonometric ratios. They come from the ratios of sides of this right angle triangle. So one is called as sine theta. So what is sine theta? So if this angle is marked as theta, this is our theta. Opposite side divided by the hypotenuse is known as the sine theta. So here we are calling the opposite side, which is height, it is y. So sine theta is equal to y divided by h, right? Then next is cos theta. So what is cos theta? Adjacent side divided by hypotenuse is cos theta. Okay, so here it is x divided by h, right? And next is tan theta. So what is tan theta? It is the ratio of sine theta to cos theta. Tan theta is sine theta divided by cos theta. So what is sine theta? Y by h, y by h. And what is cos theta? It is x upon h. So now dividing by x upon h is multiplied by its reciprocal. So we write h by x. Yeah, tell me, Izil. You wanted to say something? Alright, so tan theta is equal to then y by x. Okay, so this is sine theta, cos theta, tan theta. Then there are other trigonometric ratios also. There is cosec theta, which is 1 upon sine theta. Okay, there is sec theta, which is 1 upon cos theta. And then there is cot theta, which is 1 upon tan theta. Okay, so from our naming, it will come out to be equal to h by y, the cosec theta. Sec theta will be h by x, and cot theta will be equal to x by y. Okay, so now see, these h, y and x are not important. What is important is, if you have sine theta is opposite side divided by hypotenuse. You have to remember that. Cos theta is the adjacent side divided by hypotenuse. Okay, and what is tan theta? Tan theta is the opposite side divided by adjacent side. Okay, and then cosec is the reciprocal of sine. Then sec is reciprocal of cos, and tan is the reciprocal of cot. Cot is reciprocal of tan. So again, I am sure everybody knows this. Right, very good. After that, now you need to remember the trigonometric ratios of some special angles. Why? Because they will come again and again. So there is a trick to remember these ratios. We'll see that trick. So what are those angles? 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. These are the angles. They keep on coming again and again. Okay. So the trick is just write down the numbers from 0 to 4. Okay, first of all, write down the angles: 0, 30 degrees, then 45 degrees, 60 degrees, 90 degrees. Then write down the numbers 0, 1, 2, 3, 4, divide by 4, divide every number by 4. Okay, so this thing will be 0 by 4, this one will be 1 by 4, then this one will be 2 by 4, this one will be 3 by 4, and this one will be 4 by 4. So you have divided all of them. Okay, so 4 by 4 will come out to be equal to 1, 0 by 4 will come out to be equal to 0, right? And 2 by 4 is half. After that, take square root. Okay, take square root. So if you take square root of this thing, you will get sine theta, right? So sine theta is square root of this thing. So square root of 0 is 0. So sine 0 is 0. The square root of 1 by 4 is 1 by 2. So sine of 30 degrees is 1 by 2. And square root of 1 by 2 is 1 by root 2. Sine of 45 is 1 upon root 2. Then square root of 60 degrees, I'm sorry, what did I say? Square root of 60 degrees. Square root of 3 by 4 is equal to what? Root 3 by 2. So sine of 60 degrees is equal to root 3 by 2. Okay. And then you have 1, square root of 1 is 1. So sine of 90 degrees is 1. Okay. So actually you need to remember these, but just in case you forget, this is how you can find it out. Okay. Now to find it out also you will need some time, right? And we don't have time, that is the problem. So best thing is just remember this thing. Okay. Then how do you get cos of theta? So just write this thing in the opposite order. Just write this thing in opposite order. So cos 0 is 1. Okay. Then cos of 30 will be equal to what? It is sine of 60 degrees. So that is root 3 by 2. Then what is sine of 45? It's 1 by root 2. So 45 is special angle. So sine and cos, both of them are 1 by root 2, 1 by root 2 for the 45 degrees. Then you have sine of 30 degrees is half. So cos of 60 degrees will be equal to half, and like that. So sine 0 is 0. Cos of 90 will be 0. Okay. So for 0 and 90 it is just opposite. For 30 and 60 it's opposite. Okay. Then if you take ratio of these, you get tan. So in tan of theta, so tan of 0 degrees is equal to 0. Tan of 30 degrees is 1 by root 3. Tan of 45 is 1. Then tan of 60 is root 3. And tan of 90 is infinity. Okay. So tan of 90 is 1 by 0. That's infinity. So again, this thing, is it clear? Is there a problem? Okay. So now this trick, if you ask me where does it come from, I don't know. Okay. All right. So let's move on to the next thing. Again, you need to remember, so sometimes these ratios are positive, sometimes the ratios are negative. Okay. So for an example, you have, suppose this is the x-axis, this is y-axis, this is your triangle, and if this is your theta. So if you take opposite side, it is along the y-axis, right? It's parallel to y-axis. If you take adjacent side, it's along the x-axis. Okay. So opposite side is along y-axis, adjacent side is along x-axis. So now if you take sine of theta, it is what? Opposite side divided by hypotenuse. So this is opposite side, okay, divided by hypotenuse, right? So the opposite side is positive, hypotenuse is positive, you will take it as positive, okay, because how do you find the hypotenuse? Suppose h is the hypotenuse, then it's equal to square root of x square plus y square. Okay, it is always positive, right? So take sine. Sine will be positive or negative? So in this quadrant, this is called as a quadrant, right? So from 0 to 90 degrees, sine will be positive or negative?
Positive.
Sine will be positive because the opposite side is positive. Okay. Then if you go to the second quadrant, sine will be positive or negative? This angle goes on increasing. Suppose you go to second quadrant. Again, just think about y and x. Okay. So opposite side is marked along the y-axis. Sine will be positive or negative? Sine is positive. See, y would be positive if you go to this quadrant also. X will be negative. Right? It's simple. See, in this quadrant, x is positive, y is positive. Okay? So everything is positive. If you go to the second quadrant, y is positive, but what happens to x? X becomes negative. This is the negative x-axis. Okay? And therefore, everything related with y, right? So y divided by h is sine. Sine would be positive. Or if you take reciprocal of sine, okay, that will be h upon, it will be h upon y. So that one would be positive. That is cosec or cosecant. So they are positive and everything else will be negative, right? Everyone, this is clear, or shall I explain it? Clear, not clear? Tell me. Everyone? Yamini? Okay, good. So just remember, see, x is positive, y is also positive in the first quadrant. So all ratios would be positive. When you go to the second quadrant, y is positive but x would be negative. So sine and cosec would be positive. Okay, cos will be negative. So 1 upon cos is negative. And when you take tan or cot, so what is tan? Tan is sine by cos, right? Okay, sine by cos. Sine is positive, cos is negative, so tan will also be negative. That's why. Just sine and cosec are positive, everything else is negative in the second quadrant. When you go to third quadrant, both are negative, right? So x is negative, y is negative. So sine will be negative, cos will also be negative. Okay, sine is negative, cos is also negative. Why? X is negative, y is also negative. Sine is negative, cos is also negative. But what about cot and tan? So if you take tan, tan is sine divided by cos. Sine is negative, cos is negative. So negative by negative is positive. That negative sign, you can say, it gets cancelled out. Okay, so that's why in the third quadrant meaning, so angle would be greater than 180 degrees. First quadrant is angle is between 0 and 90 degrees. Okay, second is angle is between 90 and 180 degrees. In third quadrant, angle is greater than 180 degrees but less than 270 degrees. So only tan and cot would be positive, everything else is negative, right? And then come to the last quadrant, that is angle is between 270 degrees to 360 degrees. Then your cos and sec theta would be positive because your x is positive but y is negative. So cos will be positive, sine will be negative, right? So if cos is positive, sec is just reciprocal of that, it is also going to be positive. Okay, so cos and sec are positive, everything else is negative. Okay, so this thing is clear, everyone? Selva Kumar, this is clear? Yes, no? All right. Then next is the trigonometric ratios. I'm sorry. Next is trigonometric relations. Okay. So we have trigonometric ratios, the relations. So suppose for an example, you have sine of addition of two angles. Okay. So you have A and B. These are two angles. You want to find out sine of addition of them. So what will you do? The formula is, it is sine A cos B plus cos A sine B. Again, you just need to remember this. Okay, there is no excuse, right? So sine A cos B plus cos A sine B. Okay, it will come in oscillations, it will come in waves, it will come in wave optics, right? Many times. All right, so for an example, take sine of 45, sine of 75 degrees. So how can you write 75 degrees as addition of two angles whose sine and cos you know already? Do you know sine of 75? You don't know, right? Anybody? 30 and 45. Very good. So you can write this thing as sine of, sine of 30 degrees plus, very good, 30 degrees plus 45 degrees. So this thing can be written as sine 30 multiplied by cos of 45 degrees, okay, plus cos 30 multiplied by sine of 45 degrees. Okay, so what is sine 30? Anyone? Half. Then what about cos of 45? It's 1 upon root 2. Okay, cos of 30, root 3 by 2. And what about sine of 45? Sine of 45 is also 1 upon root 2. Okay. So then you just need to simplify this. So I guess you can take 1 upon 2 root 2 common. So that is 1 upon 2 root 2. And in the numerator you will have 1 plus root 3. If you take 1 by 2 root 2 common, then from this term you will have 1, from this term you will have root 3. So that is 1 plus root 3. And this is the answer. Now we can simplify this after this also, after this point also, but you got the idea, right? And again, there is another important thing. This root 2 and root 3 will keep on coming again and again. So does anybody know what is root 3? What is root 2 and root 3? Yeah, good. So root 2 is equal to 1.414 and root 3 is equal to 1.732. Okay, so you should remember it at least up to two digits after the decimal point. This is 1.41, this is 1.73. Okay. All right, so this thing is clear, application of this formula. Yes, no? Okay, good. Then let's see next one. Next one is sine of a minus b. Okay, so we just saw sine of a plus b, next is sine of a minus b. So only difference between the two formulas is this sine. So that was sine a cos b plus cos a sine b. This is sine a cos b minus cos a sine b. Okay, so for an example we are taking 15 degrees. So anybody tell me difference of any two angles, 60 and 45, that's good. 45 and 30, that's good. So you have multiple possibilities, right? So let's take again 45 and 30. So it is sine of 45, 45 degrees minus 30 degrees. So that is equal to sine 45 cos 30, okay, minus cos 45 sine 30. So sine of 45 is 1 by root 2. Then cos of 30 is what? It's root 3 by 2 minus cos of 45 is 1 by root 2 and sine of 30 degrees is 1 by 2. So again you can take 1 upon 2 root 2 common and it will be root 3 minus 1. Right, this thing will be equal to root 3 minus 1. Okay. So this is sine of a minus b. Then this is clear, everyone? All right, good. So then you have another ratios, another relations. I'm saying ratios again. Cos of a minus b. So it is equal to cos a cos b plus sin a sin b, and cos of a plus b, it is cos a cos b minus sine A sine B. So here there is one thing to remember, okay, one point to remember. So cos of A minus B and cos of A plus B both will have cos A cos B plus or minus sine A sine B. So if sine here is negative, then the sign here would be positive. It is cos A cos B plus sine A sine B. And if sine here is positive, then the sign here would be negative. Cos A cos B minus sine A sine B. Okay, this is clear? Yes, no? Good. All right. I'm sorry. Okay, so then there is addition of tangents. So this will not be required that often, but formulas are tan of A plus B is tan A plus tan B divided by 1 minus tan A tan B, and tan of A minus B is tan A minus tan B divided by 1 plus tan A tan B. These are the formulae. Okay, this will not be required that frequent, but we might require. Okay, so this is not that necessary, but other formulae you need to just by heart them. Okay, after that, so do you know what is positive and negative angle? So whatever angles we considered till now, they were positive. Okay, so if we are going in an anti-clockwise sense to measure an angle, those are positive angles. If we go from the positive x-axis, if we go in the clockwise sense, then those angles are negative angles. Okay, anti-clockwise sense positive angles, clockwise sense negative angles, right? So this is just a convention. Anti-clockwise is positive, clockwise is negative. After that, so trigonometric ratios of positive and negative angles, the relation between them. So this thing is must, you need to remember this. Sine of minus theta is minus sine theta. How? So you can write minus theta as sine of 0 minus theta, right? So then you can apply that formula which we just learned, right? It is sine A cos B minus cos A sine B. Sine of A minus B is sine A cos B minus cos A sine B. So it will be sine 0 cos of theta minus cos 0 sine theta, and we know that sine 0 is 0. Okay, so this first term will become 0, cos 0 is 1, therefore the second term becomes what? Minus 1 into sine theta, so that's minus sine theta. Okay, so sine of minus theta is minus sine theta, and what about cos of minus theta? It is just cos theta. In the same way, right? Same way. This is clear? Okay, good. Then next thing is half angle formulas. So what is half angle formulas? Suppose you have sine of 2 thetas. You can call it half angle formulas or double angle formulas, right? So theta is half of 2 theta, or you can say 2 theta is double of theta. No problem. Half angle or double angle. So sine of 2 theta is sine of theta plus theta, and then again you can apply that formula. It is sine of theta cos of theta, right? Here it's sine of theta plus theta. So A is also theta, B is also theta. Okay, so it's sine of theta cos of theta. Apply the sine of A plus B formula. Sine A cos B plus cos A sine B, right? Sine of A plus B is sine A cos B cos A sine B. Plus cos A sine B. So it's sine of theta plus theta is sine theta cos theta plus cos theta sine theta. Again the same thing, that is equal to 2 sine theta cos theta, and that's why you have sine of 2 theta is equal to 2 sine theta cos theta. Okay, you can apply and find it out, but now again we don't have that time. That's why we need to remember sine of 2 theta is 2 sine theta cos theta. Okay, next one is cos of 2 theta. So again you can apply cos of A plus B formula. So it is cos of theta plus theta. So it's cos theta minus sine theta. Okay, cos A cos B minus sine A sine B. So A is also theta, B is also theta. So that's why you have this formula. So it is cos square theta minus sine square theta. So this thing is clear? Yes, no? Okay, very good. So then now this formula is simple. Sine of 2 theta is equal to 2 sine theta cos theta. This one is interesting. Cos of 2 theta is equal to cos square theta minus sine square theta. And then we need to remember that sine square theta plus cos square theta is equal to 1. Okay, so this is very basic trigonometric relation. Sine square theta plus cos square theta is equal to 1. So then now see, if you just add 1 into this formula, okay, if you write 1 plus cos 2 theta, what do you get? There will be extra sine square theta plus cos square theta on right hand side, and then it will be sine square theta, and this minus sine square theta, it gets cancelled out. Then you have cos square theta and cos square theta, that is 2 cos square theta. So 1 plus cos 2 theta is 2 cos square theta, and in the same way, if you subtract that cos 2 theta from 1, you get 1 minus cos 2 theta is equal to 2 sine square theta. Okay, so this is how it is derived. 1 plus cos 2 theta, it is equal to 2 cos square theta. 1 minus cos of 2 theta is equal to 2 sine square theta. Right, this is clear? Okay, good. Then there is, okay, lot of stuff is there, lot of stuff is to be remembered. Okay, there are more trigonometric ratios, relations. So again, you have this thing, sine square theta plus cos square theta is equal to 1. Okay, we didn't prove it, we just took it as a known thing, as a fact, but you can prove it this way, right? Now if you divide this whole thing by cos square theta, so you have cos square theta plus sine square theta is equal to 1. If you divide this thing by cos square theta, then what do you get? You get cos square theta by cos square theta, that will be 1. Sine square theta by cos square theta, that is tan square theta, and 1 divided by cos square theta, that is sec square theta, okay, or secant square theta. So you have 1 plus tan square theta equal to secant square theta. Okay, so this is that formula. 1 plus tan square theta is secant square theta. Okay, and if you divide the same formula by sine square theta, if you divide by sine square theta, then you get this thing, 1 plus cot square theta is cosecant square theta. So 1 plus tan square theta is secant square theta, and 1 plus cot square theta is cosecant square theta, cosec square theta. Okay, this is clear? All right, good. Then one more thing. So suppose you have an angle and you add 2 pi into it. Okay, so angle plus 2 pi, what do you get? So for an example, let's take sine of 2 pi plus theta. Okay, so that will come out to be equal to sine theta. Sine of 2 pi plus theta, sine of 4 pi plus theta, sine of n times of 2 pi plus theta will come out to be equal to sine theta. How? So you can apply this formula. So it is sine of 2 pi plus theta is sine 2 pi cos theta plus cos 2 pi sine theta, sine of a plus b formula, right? So sine 2 pi cos theta plus cos 2 pi sine theta, and then what is sine of 2 pi? Sine of 360 degrees. Sine 0 is 0, sine of 360 is also 0. Okay, so therefore this term becomes 0, and here cos of 2 pi is equal to 1, so it's 1 multiplied by sine theta, so that is equal to sine theta. Okay, so sine of 2 pi plus theta is sine theta, sine of 4 pi plus theta is sine theta, sine of 6 pi plus theta will be sine theta, sine of any multiple of 2 pi plus theta will be equal to sine theta. Okay, so then what about cos? Cos is not there, I guess. Anyways, so what will be cos of 2 pi plus theta? Tell me. It will be cos or minus cos? What do you think? It will be cos of theta. Okay, how? Again, you need to remember this, right? You need to remember this final formula. Okay, see, so for an example, let's take cos of 2 pi plus theta. So that's equal to, we know what is cos of a plus b. It is cos a cos b minus sin a sin b. So it's cos of 2 pi cos theta minus sin 2 pi sin theta. Cos of 2 pi is equal to 1. Sin of 2 pi is equal to sin of 2 pi is equal to 0. So this term will become 0. Cos of 2 pi is equal to 1. So it's 1 into cos theta. That means cos theta only. Right? So cos of, I will just write n times of 2 pi plus theta is equal to cos of theta. Okay? So you need to remember this final formula. Okay, and I will add one more thing into that. So for an example, you have sine of pi by 2 plus theta, or you can say sine of 90 degrees plus theta. It's equal to sine pi by 2 multiplied by cos theta plus cos pi by 2 multiplied by sin theta. Then you know sine of pi by 2 is equal to 1, cos of pi by 2 is equal to 0. So second term becomes 0. This is 1 times of cos of theta. So this thing is equal to what? Cos theta. Right? So that is sine of pi by 2 plus theta. Okay, then let's take cos of pi by 2 plus theta. So that is cos pi by 2, it is cos a cos b minus sin a sin b. So cos of pi by 2 cos theta minus sin pi by 2 sin theta. So again, you have sine of pi by 2 equal to 1, cos of pi by 2 is 0. So this term becomes 0. And here you have minus 1 into sin theta, that's minus sin theta. Okay, so that is cos of pi by 2 plus theta. Right? And one more formula. You have sine of pi by 2 minus theta. Okay, it's sine of pi by 2 minus theta. So again, just apply the same thing to sine a sin b minus cos a minus cos a sin b. What did I say? Sine a cos b, and instead of plus sine you will have minus sine here, minus cos a sin b. So again this term becomes what? Sine of pi by 2, this term is sine of pi by 2 is 1. So you have 1 into cos theta. So you have cos of theta only. What about this term? Cos of pi by 2 is 0. So this term becomes 0, right? So this is also cos of theta. Okay, that's sine of pi by 2 minus theta. Okay, and let's take cos of pi by 2 plus theta. Okay, we have taken cos of pi by 2 plus theta. Now let's take cos of pi by 2 minus theta. So the difference between plus and minus is just this sign becomes positive here. So what do you have? Cos of pi by 2 cos of theta and plus sine pi by 2 sine theta. So sine pi by 2 is 1, cos pi by 2 is 0. This term becomes 0. So therefore you have only sine theta here. Okay, so that is the difference. See, sine of pi by 2 plus theta is cos theta, sine of pi by 2 minus theta is also cos theta. Okay, but cos of pi by 2 plus theta is minus sine theta, but the cos of pi by 2 minus theta is sine theta. So there is the sign difference here, right? And we need to remember this because we won't have, because every second is important. This thing will require only 20 seconds or something like that, but we should save as much time as it is possible, right? Okay, so people say that you don't need to remember many things in physics. So that is true in general, but not for NEET. Okay, because as you can see, we can derive everything, but to derive we need time. Okay, any problem in this? Any question? All right, good. Then there are some more formulae. Okay, so addition of trigonometric ratios of two angles. So sine of A plus sine of B. So where do we require them? Again, this trigonometry, most of it is required in waves, oscillations, wave optics, etc. These kind of chapters. Okay, where we play with the sine and cosines. Okay, sine A plus sine B is 2 times sine of A plus B by 2 into cos of A minus B by 2. Sine of A minus sine B is 2 times of cos of A plus B by 2 into sine of A minus B by 2. And cos A plus cos B is 2 times cos of A plus B by 2 into cos of A minus B by 2. And cos A minus cos B is 2 times sine of A plus B by 2 into sine of A minus B by 2. So I am just telling it, you need to remember. So till this point, it is absolutely important. I mean, this is must. Okay, and this thing, it will come once or twice. Okay, so now if it's very heavy for you, then you can just read this again and again. Okay, I will still say that you need to remember this thing also, but till this point it is absolute must. Okay, till here it is must. Right? So this is clear? Yes, no? Okay, good. And then based upon these things, this thing will be the homework for you today. Okay, right. So now see, we have covered 2 hours of things in 1 hour, so it will be like this, right? Okay, after that let's move on to the next topic, that is graphing. So again, everybody of you, I think you know about the graphs, right? How to plot the graphs. Okay, for an example, you have this x-axis, y-axis, and they are marked. Okay, so distances are marked on x-axis and y-axis, right? So in some units, it might be meters, centimeters, anything. Okay, then for an example, you have origin, which is 0, 0. So you will take 0 on the x-axis, 0 on the y-axis, and it comes at this point. Okay, if I want, for an example, let's take 3 2. So what will be 3 2? So 3 on the x-axis, okay, and 2 on y-axis. I will take 3 on x-axis, 2 on y-axis, so it will be this point. 3 on x-axis, I will draw a straight line from there. 2 on the y-axis, I will draw a straight line like this from there. Straight line means what? You will take a point, then you will draw a line perpendicular to that. You will take a point, you draw a line perpendicular to that, right? Perpendicular to that axis, okay? They meet at this point, so this is your point. What is this thing? It is 3 on the x-axis, it's 2 on the y-axis. So this point is 3 2. Okay, similarly, you can take any other point. For an example, you can take minus 2, minus 2, minus 2. Let's take minus 2, minus 2. So minus 2, minus 2. Okay, so you have minus 2 on the x-axis, it is this point. So draw perpendicular to x-axis from that point. Minus 2 on y-axis, it's this point. Draw perpendicular from there on the y-axis. They meet at this point. Okay, all right. So then this point is minus 2, minus 2. So this is very basic. I'm sure that you know that. Okay, one important thing to be remembered, you have, suppose x-axis, any point on the x-axis, its y coordinate is equal to 0, right? It's on the x-axis, so y coordinate is equal to 0. Then for the points on y-axis, x coordinate is equal to 0. Okay, for points on x-axis, y coordinate is 0. For the points on y-axis, x coordinate is equal to 0. Okay, very simple. Then next is line. Okay, next let's talk about the lines. So for an example, you have this line which passes through these 2 points. You have any 2 points and you can draw a straight line passing through them. Okay, so now the inclination of this line with respect to x-axis, this thing is known as slope of the line. Inclination of line with respect to the x-axis, it is known as slope of the line. And how do we find that? So if this angle is theta, so let me just get rid of these points. Okay, if this angle is theta, then slope of this line is equal to tan of theta. Okay, what is slope of a line? It's equal to tan of theta, right? So how do we find the slope? We have a formula. So slope is, that is inclination of this line with respect to the x-axis. It is rise over the run. Now you will say, what is rise, what is run? So rise means, see, you go along x-axis, then how much of difference is there on the y-axis? So you are running along x-axis, that is known as run. Okay, so when you run along x-axis, then on this line, how much of difference will be there on the y-axis? This thing is clear? Yes, clear, not clear? Okay, not everybody? Okay, good. So for this line, the difference on x-axis is suppose delta x, you can call it delta x. Then how much difference would be there along the y-axis? Suppose you take these 2 points, this is point P, this is point Q. Then difference between x coordinate of these 2 points, you can call the coordinates of this point as x1, y1, coordinates of this point are x2, y2. Okay, so point P is x1, y1, or let us write it somewhere. Yeah, it's written here, where x1 y1 are coordinates of first point, this is point P, okay, x2 y2 are coordinates of the second point, point Q. Then slope is rise or run, that is change on the y-axis divided by change on the x-axis. So rise is change on y-axis and run is change on the x-axis. Okay, so slope is denoted by this letter m. M is equal to y2 minus y1, y coordinate of second point minus y coordinate of first point, divided by x2 minus x1, x coordinate of second point divided by x coordinate of first point. Okay, so if you take these 2 points, the coordinates of point P are 1 and 0, coordinates of point Q are 3 and 3. So coordinates of Q are 3 and 3, right? So then what will be the rise? That is y2 minus y1. It's 3 minus 0. Okay, 3 minus 0 means 3. What is the run? It's 3 minus 1. Okay, change on the x coordinate. 3 minus 1 is 2. So what is the slope of this thing? It's 3 by 2. This is clear? Yes, no? All right, and then I told you that the slope of a line is also equal to what? Tan of theta, right? If the line is inclined at an angle of theta to the x-axis, the slope of a line is also equal to tan of theta. M is equal to tan of theta. Okay, right? Because this opposite side divided by adjacent side. If you think about this triangle, you can call this point anything. Let's suppose this point is M. So you have PQM in this triangle. You have tan of this theta is opposite side divided by adjacent side. So that is, you can say y2 minus y1 divided by x2 minus x1. Okay, so it's 3 by 2, right? We found it, it's 3 by 2. So that is equal to, so that means tan of theta is equal to what? 3 by 2. Tan of theta is equal to 3 by 2. And then if you know the slope, you can find out tan of this angle. Okay, so slope is given means what? Tan of an angle is given. This thing is clear? Okay, good. After that next thing is the equation of a line. So there are two forms of the equation. One is called as, you can see here, the slope point form. First form is known as the slope point form. So you know the slope and you know one point, suppose, then that is known as slope point form. Sorry, you need to know 2 points and the slope. Okay, so where does that equation come from? So you can just say from here also, here itself I can say the slope is equal to, m is equal to what? y2 minus y1 divided by x2 minus x1. Okay, I know these 2 points, right? x1 y1, x2 y2, and I know slope is equal to y2 minus y1 divided by x2 minus x1. This formula itself is an equation of a line. Okay, but it's not written in this form, it is written in this form. y2 minus y1 is equal to m multiplied by x2 minus x1. Okay, right? This thing is clear, everyone? y2 minus y1 is equal to m multiplied by x2 minus x1. This is equation of a line. Okay, so equation of a straight line is given by y2 minus y1 multiplied by, sorry, it's equal to m multiplied by x2 minus x1. This is one form. Okay, so this is known as slope point form. Second thing is the slope intercept form. Okay, so equation of a line can also be written like this, the slope intercept form. So it's nothing different, it comes from that equation only. So this equation is y is equal to mx plus c. So what's the equation of a line? It is relation between y coordinate and x coordinate. Given the x coordinate, you should be able to find out the y coordinate. Given the y coordinate, you should be able to find out x coordinate. Okay, so y is equal to mx plus c. This is called a slope intercept form. The other one where you have 2 points, it is known as slope point form. That's not important. You need to remember those two forms. Okay, this is, you can say form A, form B, whatever. Okay, y2 minus y1 is equal to m into x2 minus x1. That's one equation, and y is equal to mx plus c. Right, this is another equation. So this thing is clear, everyone? Yes, no? All right, so let's see an example based upon this thing. Okay, so this example is, write an equation let's get rid of this thing. Okay, so write an equation of a line making an angle of 45 degrees and passing through P equal to, write equation of a line making an angle of 45 degrees and passing through P equal to 2 0. 2 0 means x coordinate is 0, y coordinate, sorry, x coordinate is 2, y coordinate is 0. Okay, this one is x coordinate, this one is y coordinate, x is 2, y is 0. Okay, so you can say this is the equation, y2 minus y1 is equal to m multiplied by x2 minus x1. And now let's write y2 equal to y, okay, x2 equal to x, right? So these are the variables. One of these, either y2 or y1, you will call it as y. The other one you will call it as, other one you will have from the given point, right? We don't need to solve these kind of things, but just for conceptual clarity, we are seeing this problem. Okay, so y2 minus y1 is equal to m times x2 minus x1. This is the equation. So we'll mark y2 as y, x2 as x. That's the first step. Then what about x1, y1? So x1 will come from here, x1 will be equal to 2 and y1 will be equal to 0, right? So this x1, y1 comes from what? It comes from the point. So what will be the equation of line? So y2 is y, okay, and y1 is equal to 0. That's equal to m multiplied by, your x2 is x and x1 is equal to what? X1 is equal to 2. So m multiplied by x minus 2. Okay, so that is y is equal to, what's m? So it says that, question says that the line makes an angle of 45 degrees with the x-axis. Okay, 45 degrees with the x-axis. So that is tan of 45, slope is tan of 45. Okay, then you have x minus 2. Tan of 45, you know it's 1 by, sine and cos is 1 by root 2 and 1 by root 2. Tan is 1. Okay, tan 45 is just 1. Okay, and therefore this thing is equal to 1. So y is equal to x minus 2 is the equation. Okay, this is clear, everyone? Yes, no? Okay, good. Then now suppose you have slope point form. It's very simple. If you have this question and slope point form, then it's very simple, right? So for an example, you just write y is equal to mx plus c, and what was your point? Your point was 2 0, right? And line makes an angle of 45 degrees with the x-axis. So this is tan of 45 multiplied by x, and this is plus c. Okay, so now what is this c? So c is an intercept. Okay, so before explaining this, I need to explain what is an intercept. Okay, I'm sorry. Okay, so now suppose you have some line, for example this line. Actually I have, for example you have this line. Okay, this line cuts the x-axis at some point, it cuts the y-axis at some point, right? It cuts x-axis at some point, it cuts y-axis at some point. Okay, so the point at which it cuts a particular axis, it is known as an intercept. So what is the x-intercept here? It's the point at which a line cuts x-axis, and it's not the point, it is x coordinate of that point. Okay, so let me be specific. X coordinate of a point PT means point at which the line cuts x-axis, right? So what's that? It's equal to 1. Okay, so here for this line, for this specific example, x is equal to 1. And similarly, what would be the y-intercept? The point at which, the y coordinate of a point at which the line cuts the y-axis. Okay, I want y-intercept, it's y coordinate of a point at which a line cuts the y-axis, right? This is clear? Yes, no? Okay, so tell me what would be y-intercept of this one? It's nearly -1. Actually, it's exactly -1, no? Almost. Okay, so y is equal to -1. Okay, this is clear, everyone? Right? It's simple. Okay, and then we can return to the same problem, this one. Okay, so if 0 is there, why 0 means what? What is this thing? Tell me. It is x-intercept, right? Y 0 means this is x-intercept. Okay, so actually to write this equation, we need y-intercept. Okay, so if we take this example, okay, example of this line, then we can write equation of the line in terms of what? Slope intercept form. Okay, so see how this is the line, you have y-intercept at this point. Okay, this is the y-intercept. Okay, and that y-intercept is known as c in this formula. Okay, so this is not x-intercept, this is the y-intercept. So y is equal to mx plus c is the equation. So y-intercept is what? It is -1. Okay, so c is equal to -1. Now what about the equation of this line? So y is equal to mx plus c is the equation. you can find out m, or it might be given. So here we can easily find it out. So what is change on the y, change on the vertical axis? It's 3. When change on the horizontal axis is 2. So what is tan of theta? Tan of theta is equal to 3 by 2. This thing is clear? Okay, good. So tan of theta is equal to 3 by 2, means m is equal to 3 by 2. Okay, so now I have explained what is this intercept. So let's just get rid of this thing. So y-intercept is -1 here. So therefore y is equal to mx plus c is your equation, and you know m is equal to tan of theta. Okay, so you have tan of theta times x plus c, and that is tan of theta is 3 by 2. So it's 3 by 2 x plus c means -1. Okay, not c means y -1. In this particular example it is -1, right? So you have this equation. This is the equation of the line. Y is equal to 3 by 2x -1. If you want, you can simplify this by multiplying by 2 to the whole equation. So then it will become 2y equals to 3x minus 2. 2y is equal to 3x minus 2. Okay, so this is how we find out the equations of the lines. Okay, this is clear, everyone? All right, very good. Okay, now we need to understand lines, then only we'll understand the upcoming topics, that is derivatives and all. That's why I'm taking this. Okay, all right. I'm sorry. Now you have suppose these lines 1 2 3. Okay, so which one is more inclined to the x-axis out of 1 2 3? Which one is more inclined? More inclined. Third one is more inclined. Correct. Right? So slope of which line would be greater? Slope of third one is greater. Exactly. Slope of third line would be greater. Okay. And that means you have theta 1, theta 2, theta 3. So slope is tan of theta. So if you have lines like this, you can easily infer that tan of theta 3 would be greater than tan of theta 2, and it would be greater than tan of theta 1. Right, tan of theta 3 will be greater than tan of theta 2, and it will be greater than tan of theta 1. Okay, then what is slope of a y-axis? Slope of the y-axis, it's infinity, because y-axis makes an angle of 90 degrees with the x-axis, right? Y-axis makes an angle of 90 degrees, and slope is tan of 90. What is tan of 90? Tan of 90 is infinity. Okay, then what is slope of x-axis? What is the angle made by x-axis with the x-axis? It's 0. So slope of x-axis is equal to 0. Okay, that is simple. Yes, so all these things that we are seeing, these are positive slopes. Okay, these are positive slopes. All right, so now suppose these are parallel lines. So slope of parallel lines will be equal, right? If two lines are parallel to each other, 2 3 4, any number of lines are parallel to each other, the slope should be equal. If they are parallel, that means now if you take x-axis, each line will make same angle with the x-axis. Okay, so this line, this line, this line, all of them make same angle with the x-axis, and therefore Therefore, slope of all of them will be equal, because tan of theta, right, tan of the angle made by the line with the x-axis for all these three lines would be equal. So therefore, slope is equal, right? This thing is clear? Yes, no? Okay, good. All right. So then, now you can find out slope for any one of them. Okay, for an example, you can find out slope of this one. Okay, and that thing will be slope of each of the line, right? All right, and one more thing. How do we write equation of these three lines? Slope will be equal for all of them, but will the equation be equal or will the equation be different? Equation will be different because they are not same lines, they are parallel lines. Okay, it's not the same line, they are parallel to each other. So we should be able to identify which line is which one. So each line will have its own equation. All right, so how do we find the equation? So suppose you have this line, okay, and here it's given it cuts the y-axis at 2 by root 3, and it cuts the x-axis as minus 2. Okay, then you have this formula y is equal to mx plus c, right? So you can find out m, change on the horizontal coordinate divided by, sorry, change on the vertical coordinate divided by change on horizontal coordinate. Okay, what will that be equal to? Root 3 by 2, sorry, it's 2 by root 3 divided by what? Minus 2 or plus 2? Tell me if you have this line, okay, and this problem can be there. For an example, you have x versus t graph, xt graph. X is the position and t is the time, and you are asked to find what is the speed. Okay, that is a possibility, right? So speed will be the slope of xt graph. We'll see that. Okay, so we should be able to find out the slope. Now here the slope is positive or negative? Tell me. Slope of this line, positive? Everyone? Yes, Indusha, is it positive, negative? It cuts the y-axis at positive. Good. Cuts y-axis at 2 by root 3, cuts the x-axis at minus 2. All right. So whether the slope is positive or negative, it doesn't depend on where it cuts. Okay. So what do I mean by that? So what is important is you run along positive x-axis. If the difference in y is also positive, then the slope would be positive, right? So you start from minus 2 and you go towards 0. Okay, you went till this point, so you are running along positive x-axis. How much distance did you cover? It's minus 2 to 0, means 2. This much distance is 2. Then the difference in y is also positive, right? So the y coordinate is going up when you run along positive x-axis. Then the slope would be positive, right? And how much is it? It's 2 by root 3, okay, divided by 2. Okay, that's 2 by root 3. 2 by root 3 divided by 2 is that 2 will get cancelled out. Okay, so what will be equation of this thing? Tell me. 2 by root 3, slope is 2 by root 3 divided by 2. Divided by 2. 2 gets cancelled out, so it's 1 by root 3. Then equation of the first line. Okay, what will be equation of first line? Line 1, y is equal to mx plus c, right? So m you found it's 1 by root 3, okay, 2 by root 3 divided by 2, right? So 1 by root 3 times x plus c. Now where is it cutting the y-axis? At 2 by root 3. So c would be equal to what? 2 by root 3. Okay, this thing is clear, everyone? Right, what about the second line? Tell me, equation of line 2. Now you tell me. Yes, everyone? Y equals to 1 by root 3 times x, right? Okay, because it cuts the y-axis at 0. It is passing through the origin, means x-intercept is 0, y-intercept is also 0. Okay, so c is 0 and therefore the equation is just y is equal to 1 by root 3 x. And what about line 3? It is cutting the y-axis at minus 2 by root 3. So therefore the equation is y is equal to, slope is equal, y is equal to 1 by root 3 times x plus c is minus 2 by root 3. Okay, so this is how we find out equation of line, right? Of course we know that how to find the equation, but these are equations of these three lines and these are parallel lines. Slope is equal but equations would be different. Any doubt in this? Anybody? Tell me. No doubt? Good. Then okay, so now suppose equation of a line is given and then we should be able to draw the lines, but that's not important for us. So I will just keep this, or shall I explain? Okay, let me explain, no problem. So for an example, this equation is given, okay, and I want to plot the line. Okay, so y is equal to root 3 times x plus 3 is the equation and I want to plot the line. Okay, so from here you know that slope is equal to what? Root 3, and root 3 is equal to tan of theta. Okay, so tan of theta is equal to root 3, means the angle is equal to what? It's equal to 60 degrees, because tan of 60 is root 3, right? Okay, so theta equals to 60 degrees. You have this. Okay, so this line makes an angle of 60 degrees with the x-axis. Okay, but there are multiple, actually infinite number of lines which make an angle of 60 degree with the x-axis. So what would be this line? So it cuts the y-axis at 3 when x coordinate is 0. Okay, it cuts the y, yeah, of course the x coordinate will be 0. It cuts the y-axis at 3. Okay, so x coordinate of whole y-axis is 0, right? So you need to draw a line. Okay, so slope is what? Root 3, means it makes an angle of 60 degree with the x-axis. Okay, so now you got one point. So put x equal to 0, then you will get what? Actually, this was the information. Put x equal to 0 here, so you will get 1 point. What's the value of y? Okay, if you put x equal to 0, you get y equal to 3, so that is the y-intercept. If you put y equal to 0, then you get root 3x plus 3 is equal to 0. Okay, root 3x plus 3 is equal to 0. Then you take this 3 on the other side, then you get root 3x equal to minus root 3, and therefore x is equal to minus 3 by root 3, that is minus root 3. Okay, so you only need 2 points to plot a line, and this is your first point. Okay, when x is 0, y is equal to 3, right? And you have second point. Second point is what? When y is equal to 0, x is equal to minus root 3. Okay, so then you take these 2 points and you mark those points and draw a line passing through those points. So this is how you plot a line given the equation, right? So that is simple. This thing is clear? Yes, no? Okay, so given the equation, we can read the equation, we can find out the slope, we can plot the line. All right. So this is little homework based upon that. Okay. Next, let's see curve plotting. So curve plotting is not different. It is just like plotting a line, right? If we know how to plot the line, if we know how to plot the point, we know how to plot anything. So a curve will have some equation. For an example, you have y is equal to x square. This is the equation. Okay. So then you just need to take some values of x, and for those values of x, you will get corresponding values of y. So this is suppose x. Okay. So you put x equal to 0, then y will also be equal to 0. You got 1 point, right? Take x equal to plus 1. What will be the value of y? Y will also be equal to 1. Okay, you got another point, right? If you take x equal to minus 1 also, then minus 1 square is also 1. So y will be equal to 1. So for x equal to 0, y is 0. For x equal to plus or minus 1, y is 1, right? For x equal to plus or minus 2, the y is 4. Okay, because 2 square is 4, minus 2 square is also 4. So for x equal to plus or minus 2, y is 4. Okay, x equal to plus or minus 3, y is equal to 9. Okay, so then you just plot these points. So x equal to 0, y equal to 0 is this point. X equal to 1, then y will be also equal to 1, it is this point. X is minus 1, then y is equal to what? Y is also equal to 1. Again, this is this point. So and then you join those points, right, with a free hand, and you get a curve. So this is curve plotting. This thing is clear? Yes, no? Everyone? Good. So now, more than plotting a curve, we should be able to how to read the curve. Okay, that is important, right? Yeah, we need to know both things, but reading a curve is very important. So for an example, now suppose I want to find out slope of this curve at some point. What should I do? We know how to find out slope of a line. I want slope of a curve. What should I do? Anybody? Alright, it's very simple. What should we do is, suppose I want to find out slope of this curve at this point. What will I draw? I will draw a line which is tangential to the curve. Okay, so you know tangent means a line which intersect the curve, sorry, a line which touches the curve at one and only one point. That is called as a tangent. the line which intersects the curve, yeah, that is also true, line which intersects the curve at one and only one point. Okay, so this line is not a tangent because it will cut the curve at this point as well as this point, so it's not a tangent, right? The point should cut the curve at only one point. Line should cut the curve at only one point. So this is the point, suppose, and I want to find out slope of this curve. So what should I do? I will draw a tangent to the curve, that will be a line. Okay, and if you look closely, so see here, if you zoom it infinitely, the slope of this curve at that point and slope of the tangent, it would be equal, because if you take small portion of curve, very small portion, then it is like a line only, right? Very small segment if you take, it's like a line. Okay, so slope of this line and this line would be equal. This thing is clear? Okay, so this small segment and the tangent, they almost overlap, right? So slope of this one and this one would be equal. So what is slope of a graph? So a graph or a curve will have different slopes at different points, and if you want slope at a particular point, what will you do? You will draw tangent to the curve. Okay, slope at a particular point, I will draw tangent to the curve. So slope of the curve at that point is slope of tangent at that point. This thing is clear, everyone? Yes, no? Okay, very good. All right, then each curve will have some equation, right? Each curve will have some equation, and this thing is known as a function. Okay, so equation is known as a function if for each value of x you get only one value of y. Okay, okay, I'm telling one more thing, right? So the equation is known as a function. When is it known as a function? When for each value of x you get only one value of y. So this x is called as an input. You are giving the value of x and you are trying to find out the value of y, right? You are giving the value of an input, that means you are giving the value of x and you want the value of y. So for each value of x you get only one value of y, then that kind of an equation is known as a function. That is relation between x and y, it's known as the function. So what is a function? Function is input output relation. Okay, so for each input you are getting only one for each input you are getting only one output, then that thing is known as, that relation is known as a function. This thing is clear? Yes, no? Everyone? Function is input output relation. You can think of it like a box. Okay, so for each value of x you get only one value of y. For each value of input you get only one value of the output. Okay, then that's a function. There are lots of different kinds of functions. There are trigonometric functions. Okay, the ones that we studied today, they are known as trigonometric functions. The trigonometric ratios we have, no, they are known as trigonometric functions. Okay, so for an example, you have sine x. So if you say y is equal to sine x, okay, you write equation between y and x, relation between y and x, and you say y is equal to sine x, then Is this a function? Yes, no? Tell me. Is this thing a function? Okay, instead of trig functions, I will just say functions. Okay. So all trigonometric ratios are functions. Why? Because for one value of an angle, you get only one value for that ratio. So that's a function. This thing is clear. So all trigonometric ratios are functions. Okay, so y equal to sine x is a function, y equal to cos x is a function, right? Then equation of a line is also a function. Equation of a line is also a function, right? So y is equal to mx plus c is a function. Okay, because for each value of x you get only one value of y. This thing is clear? Yes, no? Okay, so to explain this in better way, I need to tell you what is not a function, right? So for an example, y is equal to root of x is not a function. Okay, square root is not a function. Is not a function. Why is it not a function? For an example, let's take y equals to y is equal to root x is not a function. Why? Because for an example, you have x equal to 4, then you have y equal to plus or minus 2. So for one value of x, how many values of y do you have? You have two values of y, right? For one value of x, you are having two values of y. Yes, no? So what is a function? A relation where for each value of x, you are having only one value of y. So that's why this relation doesn't qualify to be a function. It's clear? Not clear? Okay, this is not a function. Okay, and let's take another example, similar one. If you take equation of a circle, equation of a circle, right? So what is the equation of a circle? X square plus y square is equal to r square is the equation. X square plus y square is equal to r square. Okay, this is the equation. So you have y square is equal to what? R square minus x square, and therefore what will be y? It will be square root of that. So if square root is not a function, that means this thing is also not a function, and that's why equation of a circle is not a function, right? So this is not a function. Is this thing clear, everyone? Okay, all right. So then there is another example. Y is equal to e raised to x. This is known as an exponential function, and it comes naturally in physics, in economics, etc. We don't need to care about that. But y equal to e raised to x, this is a function which comes naturally. Okay, now anybody of you had maths earlier? In your 12th? Okay, so this is known as exponential function, right? This is known as what? Exponential function. So you have, suppose, this e. What is e? E is equal to 1.71 something. Okay, it's equal to 1.71 something. Now you take values of x. For that you will get values of y. So for x equal to 0, what will be y? Now you need to remember this: anything raised to 0 is equal to 1. Okay, 1 raised to 1 is 0, 2 raised to 1 is 1 raised to 0 is 1, 2 raised to 0 is 1, 3 raised to 0 is 1. Anything raised to 0, anything raised to the power 0 is equal to 1. Okay, so e raised to 0 is also equal to 1. So for x equal to 0, y is equal to 1. Okay, so you get this point. This is your first point. Okay, then for x equal to 1, y is equal to what? It should be equal to e raised to 1. So y is e. You get that second point, this one. Okay, similarly you take x equal to minus 1, x equal to minus 1, y is e raised to minus 1. So e raised to minus 1 means 1 upon e raised to 1. Okay, e raised to minus 1 means 1 upon e raised to 1. Okay, so now therefore y will be equal to what? 1 upon e raised to 1. Okay, so you get this point, right? 1 is here, so 1 upon e. If e is greater, this point will be smaller. Okay, this point means value of y will be smaller. Okay, so if you go to the negative values, it will go on decreasing. If you go to positive values of x, it goes on increasing. But if you come from minus infinity, then how will the graph look like? It will look like this. So this function is known as exponential function. This thing is clear? Yes, no?